Hello everyone and welcome back to the series on maps and sets. This is going to be the last practice problem of this series. In our previous video we discussed subarray sum equals k problem, and to solve it efficiently we used a maps based approach which helped us solve the problem in big O of n time complexity. So I'll quickly give an overview of the approach that we used. But if you are new to maps and you haven't watched the previous video, I would highly recommend to quickly go through the video. The link must be somewhere on the top right corner of your screen. So in the last problem that we discussed, we had to find the number of subarrays with sum equal to k. So let's briefly discuss the approach we used. As we were parsing the array, we kept computing the sum till the current position. While doing so, we were also keeping a track of how many times we have seen a particular sum value. So to keep the track of the number of occurrences of a particular value, we used a map. So in order to quickly explain the approach, I'll take an example. So let's say that our example array is something like u, v, w, x, y, z, a. So now our core logic was that if we have 2 points in an array, so let's say that we have 2 points, first is this point and second is this point. Now if the sum till the first point is z and the sum till the second point is z plus k. So when I say that sum till this point, I'm actually referring the sum of all the elements from start till this point. So this is z represents sum of u and v, and z plus k represents the sum of u, v, w, x, y. Now in this particular scenario, we can definitely say that the sum of the subarray starting from w and ending at y is going to be k. So for every sum s, we used to check our map and find the occurrences of s minus k till now. So if the current sum is represented by s, we used to find the frequency or the occurrences of s minus k, and we used to search in our map for the frequency of occurrences. So the number of occurrences of s minus k gives us the number of subarrays ending at the current point and having sum equal to k. So now, as we discussed in our previous video also, this approach can be used in a variety of questions, and it comes in really handy when dealing with substrings and subarrays. So in this video, we are going to solve another problem that can be solved efficiently using the same approach. So today we are solving Leetcode problem 523, continuous subarray sum. So the problem statement states that given an integer array nums and an integer k, return true if nums has a continuous subarray of size at least 2 whose elements sum up to a multiple of k, or false otherwise. So as always, the first approach is the brute force approach. We can check the sum of each possible subarray and see if any subarray has a sum which is a multiple of k and return true and false accordingly. One thing that we need to keep in mind is that we only need to check subarrays of size 2 and above. So the total number of subarrays is going to be of the order of n square, where n is the size of the array. So we know that the total subarrays are n into n plus 1 by 2, where n is the size of the array. But we won't be considering all the subarrays of size 1. So the total subarrays are actually going to be n into n plus 1 by 2 minus n. Now in the previous video, we have discussed how we can find the sum of each subarray efficiently in O1 time. So the total time complexity for checking each subarray is going to be big O of n square. Now let's come to the optimized approach. Let's try to analyze how we can use the previous map-based approach. So let's take an example array. So let's say that our example array is A, B, C, D, E, F, G, H, I, J, K, L, M, N. Now let's assume that the sum till the point C is x, sum till F is x plus k, sum till J is x plus y into k, and the sum of the complete array is actually x plus z into k. Now let's try to find the sum of few subarrays. So the sum of subarray from C to F is actually going to be k, and the sum of subarray from C to the point J is going to be y into k, and sum of subarray from C to N, or the last element, is actually going to be z into k. Not just this, the sum of the subarrays from f to j and then f to n and also from j to n, all these are going to have a sum which is a multiple of k. So it seems like that our earlier approach can be of some use here, because by keeping the track of all the values of sum that we have received till now, we can actually find the subarrays whose sum is going to be a multiple of k. The only problem here is that in our earlier approach, if the sum was s, we had to just look for s minus k in the map. But in this case, if sum is s, we need to look for multiple possibilities. So if the current sum is s, and if we have encountered s minus k, s minus 2k, s minus 3k, or say s plus k, s plus 2k, s plus 3k, and so on. So all these possibilities, if any of these possible sum values are actually present in map, we are going to get a subarray which is going to be a multiple. We are going to get a subarray whose sum is going to be a multiple of k. So we can see that the number of possibilities that we need to check are huge. And as evident, this problem stems from the fact that our sum value is not bounded. So there are a huge number of possibilities. So the solution for this problem can be that instead of computing and processing sum, we start computing sum modulo k. So this would give us the remainder when sum is actually divided by k. So now let's say that the sum at any point is s, and the remainder for s mod k is equal to x. So if we get this same remainder again somewhere, that would imply that the sum of elements between these 2 points is divisible by k, because the remainder has repeated again. So let's try to prove this using an example or mathematically. That would be more intuitive. So let's say that our example array is a, b, c, d, e, f, g, h, I, and j. Now let's say that the sum till c is s1. So sum of this subarray is s1, and sum from d to f, or the sum of this subarray, is s2. So this is s1 and this is s2. Now let's say that the remainder at c and f are equal. So what we are saying is that s1 mod k is equal to s1 plus s2 mod k. So the sum till point c is s1 and the sum till point f is actually s1 plus s2, and we are saying that the remainder at both these points are equal. So we get this equation. This can be further simplified and written as s1 mod k is equal to s1 mod k plus s2 mod k and whole of mod k. So this is the property of modulo. So from this equation, we can see that s2 mod k equal to 0 is actually a solution of this particular equation. And this statement implies nothing else but that s2 is actually a multiple of k. And since s2 was the sum of this subarray, so we can say that the 2 points where the remainder repeated, the sum of the elements between these 2 points is actually going to be a multiple of k. So let's take a proper example and try to understand this. So let's say that the input array is 1, 4, 5, 7, 1, 6, and k is 12. Now the sum till 4 is 5, and 5 mod 12 is 5. So the remainder is also 5. And again the sum till 7 is actually 17. So it is 1 plus 4 plus 5 plus 7. And 17 mod 12 is again 5. So we can see that at these 2 points the remainder is actually repeating. Now if we find the sum of elements between these 2 points, that is 5 and 7, the sum of 5 and 7 is 12, which is actually a multiple of 12. So our trick actually works. So instead of storing the sum, we will store sum mod k every time, and we just have to look in our map to find previous occurrence of just one value, which is sum mod k, which is the remainder at that point. So we have actually solved the problem wherein we had to check multiple possibilities in our map. So let's quickly go through the working code for this particular solution. So our main method is check subarray sum, which is going to be called by the driver function, and we have a input nums array, and then we have int k. Now we are using a map to store the previous occurrences of the remainders, and in this map we are actually storing remainder versus the index where this remainder last occurred. So why we are not storing the frequency? Because in this question we just need to return a bool value whether there exists any subarray which has a which is a multiple of k. So we don't need to find the total number. So instead of storing the frequency, we are just storing the last occurrence of that remainder. So obviously we first initialize our sum variable. So this sum variable is actually going to store the sum till that point. And as we can see that we are not actually storing the exact sum, but we are storing sum mod k. So we have initialized it with the first value of the array, and we have taken a mod, and we have also added our entry to the map because this sum has first occurred at 0 index. So against this sum in the map we have stored 0 index. Now we start computing from the second element of the array. So we calculated the sum till that point. So again we are not calculating the exact sum but sum mod k. So we have calculated sum mod k. Now there are two possibilities. So when sum is 0, it is the case when the sum of the subarray from start till that point is actually a multiple of k itself. So we have actually found one subarray whose sum is a multiple of k, so we can return 1 in that case. Now the other case is that the sum of the whole subarray from start to this point might not be a multiple of k, but there exists a point and the sum of subarray between these 2 points is actually going to be a multiple of k. To find that possibility, we would have to search in our map. So as we discussed, we try to find that if we have received this remainder before, so the remainder here till this point is stored in the sum variable, and we try to find that is there a past occurrence of this remainder in the map. So we are using the find method to check whether this remainder exists in the map or not. So in case if the sum or the remainder itself is 0, or in the case where this remainder has actually occurred at some point in the past, in both the cases we need to return 1. So if the sum is equal to 0, we return 1. And if this past remainder has occurred in our map and the last occurrence is not at I minus 1, if the last occurrence is at I minus 1, then the subarray that we are looking at is actually of size 1. So what we are trying to say that in an array abcd, the remainder at this point is x, and again the remainder at this point is x. So we are saying that the subarray between these 2 points is actually having a sum equal to k. So the subarray between these 2 points is actually of size 1, and the question clearly specifies that we need to check for subarrays of size at least 2. So if the sum is 0, then we have returned 1. And in the other case where this remainder actually occurred in the past, we make sure that this remainder did not occur just at the previous position, because then we would be looking at a subarray of size 1. So if it occurred at some other position and not just I minus 1, then we are looking at a bigger subarray, so we can return 1. But if we are looking at a subarray of size 1, we just continue our loop because this is not the correct answer. And in the else condition, we just make an entry for the current remainder. So we have added the current remainder in our map and we have updated the index against it. So this loop continues, and if there's any subarray whose sum is a multiple of k, we would return 1 from either of these two conditions. If we do not return 1 from any of these conditions, if these lines are never executed, that implies that there was no subarray whose sum was actually a multiple of k. So at the end we return 0, and 1 obviously represents true and 0 represents false. So the time complexity is again big O of n. We are traversing the array linearly once and doing insertion, searching and update in each step. So insertion, searching and updating in a map takes O1 time. So the total time complexity is equal to the time complexity of passing the array. So the time complexity for this solution is big O of n. With this, we have reached the end of this video as well as this series. Hope you learned something new from this series. Now it's your turn to go online and practice as many questions as possible and post your doubts in comment section below. So I'll be back with another series very soon. Till then, stay safe and keep learning. Bye bye.